What I've done here is to combine sections 2.2 and 2.3. And the reason being some basics information here. So there's no need to have two separate PowerPoints. Here again, we're still organizing data. And what these guys are looking at this gentleman here, I'm not quite sure what's going on, but you can figure that out. Cheetahs, I guess. This one here looks like he's ready to attack. All right, bar graphs, circle graphs, time series graphs, things you've been doing since elementary school, bar graphs and circle graphs. Like time series, not so much. I'm asking you to watch the two videos. 2.2 is a little long. It's about 24 minutes, and 2.3 is about 7 minutes long. These won't play right out of my voiceover. And actually, to get them play, even when you out of Canvas, when you view them in Canvas, the link won't be there. The only way you can actually view these is I have links to them, hyperlinks to them. But if you actually download the PowerPoint, they'll play right out of it. If you don't own PowerPoint, beginning of the course, I gave you a link because by virtue of being a student of Massasoit, you can download Office 2019 for your charge, and I gave you some directions on how to do that. So please take advantage of that. So there's 2.2. And there's 2.3. These won't play out of the video, but if you download the actual PowerPoint, which is a link in Canvas, it'll play right out of there. And I have a second link as well, all kind of ways. And then I also have all videos. You can click on those and see all the videos for the course. Find 2.2 and 2.3. Please take the opportunity to watch these. Histograms provide a useful visual display. Sure, we've seen that. The difference between a histogram and a regular bar graph is the bars are right up against one another. There's no space. Just another way of doing things. Is it making it easier? That's up to the end user. If the person can understand what you're trying to portray, whatever reason you're doing the graph for, is it for your company or if it's for an organization that you happen to be involved in, and you got tasked with presenting some data via graphs, organizing and displaying some information. So which one is better? It's hard to say. Um, he says, however, with the histogram, the data must be quantitative. All right, numbers. In this section, we examine other types of graphs, some of which are suitable for qualitative, non-numerical data. So bar graphs. A bar graph can be vertical or horizontal. The bars are uniformly in width and uniformly spaced. The length of the bars represent the values of the variable being displayed. The graph is annotated with titles and labels. Each bar in vertical scale or actual value of the length of each bar. So it has to be labeled so people can understand what it is you're trying to portray them. Trying to portray. If I can spit it out, I'll be good. There's a saying with statistics: there's lies and there's damn lies, and then there's stats. Pretty much, you can make statistics if you kind of grimy. You can make them say anything you want them to say, especially if you're talking with a uninformed end user. These two graphs portraying the same data, life expectancies of men and women. Now, assume this. Picture this. I'm a kind of a weasel of a insurance salesman. I walk into a home and instead of showing the married couple a couple this graph, I show them this one here. Now notice it's the same data, but the discrepancy between the man's life expectancy and the woman's is more pronounced. But if I look at this little squiggly line here, you can see what's going on. The scale, the vertical scale goes from 0 right to 65, but this one is uniform from 0 to 20. If I was trying to sell insurance to a couple, I would show them this because the wife would say, look, I'm going to live that much longer than you. I got no insurance. And you can see how games can be played. Same data, but just the way it's portrayed. All right. And that's a giveaway that the scale has changed. All right. These two bar graphs depicting life expectancies. Important feature is that if the change in scale from 0 to 65, the changing scale amplifies the apparent difference between lifespans of men and women. So you can see that if you were a a grimy little salesman, you may show the other graph just to elicit some reaction. You want to make a sale. You want to sell some life insurance. He talks about this little squiggly line, meaning, hey, there's been a change in the axis. Now, whether or not the insurance salesman would put that, or whether the end user would actually be aware of what's going on. That's the games that can be played with statistics if you're not aware of what's happening. All right. Pareto chart is a special type of a bar graph in which the bar heights represent frequencies of an event. In addition, the bars are arranged from left to right according to decreasing height. Another popular pictorial representation is the circle graph, right, where the total quantity is 100% of the entire circle. This is an example of the Pareto chart. All right, how do people land jobs? Networking, newspaper ads, internet, apps in person, employment agency, and through school. But the idea is they're listed with the highest frequency first onto the lowest. Pareto chart. Circle graph, you've been doing these since you were probably in 4th or 5th grade. All right, pie chart, circle graph, labeled properly. And the thing people forget is that to accurately create a circle graph, you got to realize that there are 360 degrees in the circle. So in this particular case, the number of people on the phone for less than a half an hour was 296, but there are a total of 500 people. So 296 represented 59.2% of all the people that were surveyed. Now, take 59.2% and multiply it by 360 degrees. That's what gives me that the central angle, that's what's called in geometry, the central angle is 213 degrees. It's found by taking the count, dividing it by the total, changing that to a percentage, and then multiplying by 360 degrees. The same thing happens with the number of people that are on the phone from a half an hour to an hour. 83 out of 500 represents 16.6%. Now, to come up with this angle here, the central angle of 60 degrees, I took 16.6%, multiplied by the entire revolution of a circle, 360, to come up with 60 degrees. Then the last one, if you have 213 and 16, notice the last one has to be 87 because the total of all three is complete revolution, 360. Time series graph, the data are appropriate for a time series graph because they represent the same measurement distance covered in a 30-minute period taken at different times. The measurements are also recorded at equal intervals every week. Here's an example of jogging distances, jogging times. Week 1, person jogged 1.5 miles. Week 9, they were almost up to 2, and then by week 20, they were up to, maybe 3 3/4. Time series, pretty simplistic. All right, you have little dots representing the distance that they jogged, and then they're connected with little lines. Call it time series. Of course, 20 weeks, the distance that they traveled. Another way of representing data. How to decide, bar graph, useful for quantitative and qualitative data. Pareto charts identify the frequency of events. Circle graphs display how the total is dispersed. Time series, how data changes over time. But the key thing is for any graph, whatever you decide to use, you need a title, you need to label your axis, you need to identify the units of measure and so forth. You got to make it easy for the end user to read and decipher what it is you're trying to tell them. Stem and leaf, yeah, you'll be asked to do this one. It's really simplistic. It's a method of exploratory data analysis that is used to rank, order, and arrange data into groups. A stem and leaf is a device that organizes and groups data, but allows us to recover the original data if we need to. In the next example, we'll make a stem and leaf. Many airline passengers seem weighed down by their luggage. Just how much weight are they carrying? Here you've got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess it's 10 columns for 40 people and the weights of their carry-on luggage. All right, 40 people. So we need to make a stem and leaf. The left group of digits is called a stem, and the remaining group of digits is called the leaf. Stem and leaf, I got it. We're free to choose the number of digits to be included in the stem. The weights in our example consist of 2 digits. The stem will obviously be the left digit, the tens digit, and the right digit will be the ones, the leaves. So, for example, the weight of 12, the stem would be 1, the leaf would be 2. All right, 18, stem is 1 and the leaf is 8. I don't mean to laugh, but it's part of the course, so you take advantage of it. How straightforward and easy this is going to be. 3, 2 represents 32 pounds. 1 and an 8 would be 18 pounds. A 4 and a 5 would represent 45 pounds, and so forth. Stem and leaf. In this case, the stem is a tens digit and the leaf is a ones digit. All right, so these numbers here we represent. This is the stem, so these 3 numbers represent the 3 values of 60, 4 values of 64, and 5 values of 68. This would represent 124. The stem is a 12, and the leaf is 424. You get the idea. Stem and leaf could be much easier. Finally, we order the leaves as shown. The next figure shows the stem and leaf for the weights of the carry-on luggage. And I guess I never did that. All right. These are, don't mind the phone ringing, that obviously happens. Sample of 32 cowboys and their longevity. I'll wait till this phone stops ringing. This woman would call, wouldn't she? Okay. All right. This cowboy lived to 58 years. This guy lived to 93. We want to make a stem and leaf. So, oh gosh. All right, man. We'll call you back tonight. Nice timing. Anyways, longevity of cowboys. All right. So the 4-7 represents that one of the cowboys lived to 47 years old. There it is right there. 52, 57, 58, and 58. You'll find them there. Stem and leaf. This is your stem. The units digit is your leaf. No biggie. Here he talks about it. Frequency polygon, another type of graph. We're looking at the heart rates of women in the next graph in line segments that connect the different values. All right, pulse rates, same thing, heart rates. These are for women, and then you have men in green. Yeah, somebody's heart rate, 124. Heart rates, I know this because of my 96-year-old mom. Heart rate should lie somewhere between 60 and 100. So if you're at 124.5, your heart rate's pretty fast. You need probably be on some medication. But anyways, that's the idea of a frequency polygon. It's just a line that connects the little dots that represent the pulse rate of women in this graph and then men and women in that frequency polygon. Scatter plot, it's like plotting X and Y values, ordered pairs. Back in intro algebra, graph ordered pairs. That's what a scatter plot actually is. Here we have temperature, and then we have chirps, crickets. Why someone would be interested in how many times a cricket chirps. But there's people collect data on all sorts of crazy things. I guess if you get some sort of a grant, you get out there, you start counting chirps. All right, so you can see what's happening here as the temperature increases. These crickets are more active, they're chirping away. Who knew? This is something else that you'll see on an exam. It's a dot plot here again. It could be more simpler. Right here again, pulse rates of women. There are 3 women who had a pulse rate of 60. Looks like there were 4 women who had a pulse rate. It looks like 64. You got one person out here at 96, and this woman here, pulse rate of 124. She needs to see a doctor. That's extremely high. In fact, 105 isn't all that bad, but that's tough. How many dot plot? Average hours spent sleeping at night. One person sleeps 5 hours, one person 9 hours, and this looks to be 4 people that sleep 6.5 hours. One person is 5.5. Thought plot, no big deal. And that's all there is for 2.2 and 2.3. Moving on to chapter 3, but that much wraps it up in 2.2 and 2.3. As you can see, really simplistic stuff. Trust me, it'll get more challenging.